All right. Hi, everyone. Thank you so much for joining us for our robotics engineering department session for accepted students. My name is Sydney Trahan. I'm an admissions counselor at WPI. We all have territory responsibilities, and mine specifically are Long Island, New Hampshire, Kentucky, and Wisconsin. But I am not going to be presenting today. I will let Greg take over and let everybody introduce themselves, and yeah, take it away.
Hello, I'm Greg Lewin. I'm the Associate Head of Robotics Engineering, and I'm glad you could join us, and we're going to be happy to talk to you about the program that we have here. We have some people who will be able to answer questions in the chat while I'm talking. So while I'm giving a presentation, if you have questions, feel free to put them in the chat and they'll be answered here. And then we should have some time at the end where you can ask more questions and we can answer them verbally. So I'm joined by Ken Stafford, who's a professor emeritus. He actually was one of the people who started the program many years ago. Ken, I guess I'll let you introduce yourself, sorry.
Yeah, welcome and congratulations to you folks that have all been accepted to this wonderful school. I've been a professor at WPI for about 28 years, I guess. And like Greg said, I was a former associate head of the program and as one of the people that got the program started. So I've got appointments in robotics engineering and mechanical engineering and aerospace engineering. So I'm happy to answer any questions that might come up on that. Currently, I'm in Morocco with a bunch of WPI students where they're doing their junior projects, one of which involves robotics, which is way cool. And so it's 10:30 or 10 o'clock my time at night. But anyway, welcome aboard, and I'll be happy to answer any questions that pop up in the Q&A.
We're also joined by Ash Andrews, who is a second-year double major in robotics and computer science, right? Ash, you want to introduce yourself?
Yeah, I'm Ash, sophomore here at WPI. I've been a robotics engineering student the entire time, but I just recently added the CS double major.
And then also Tom, who is in the robotics program. He's in the bachelor's master's program. So he might be able to answer questions about that as well. Tom, if you want to say a couple words.
Yeah, I'm a rising junior, trying to do the BSMS in about 4 years. So I kind of came in with a kind of a plan already, so I can help with any kind of stuff like that.
And just so you know, we like to invite students to these things because they're able to answer some of the questions better than we are. For example, when you ask it, how easy is it to double major? I say, I don't know, because I was a biology major when I was an undergraduate, but Ash may be able to help you answer that. And so you might get a good perspective from them as well. So with all that said, let's get started about hearing about robotics engineering. So first of all, congratulations, you've been accepted. I suspect you've been accepted more than one place, or many of you have been accepted more than one place. We're here to tell you about what WPI has to offer, and we hope that it would be a good fit for you and that you would like to come here to study robotics. So I'll start with a little here. Take a minute for it to show up, but we don't really have one robot for every 3 students. Although sometimes it might feel like it when you're on campus and you see robots driving around. I'll stop the, whoops. So I'll stop the video real quick, but my favorite part about that video is not only the robot is really cool, but the way that the students react to it, because most of them just kind of sit there and say, look, a robot's going by. Because it happens around here. We have we do lots with robotics at WPI, and people are used to it, and it's a very important part of what we do here, and a lot of people understand that. It's so important that we've actually designed a lot of buildings with robotics in mind. In 2012, they built a new sports and recreation center, but it's not just a sports and recreation center. Excuse me. It also houses what we call the robot pits. So they designed a large space where we could host competitions. So this is where people who are participating in the competitions come and they prepare their robots, and then we actually have a tunnel that connects it to the the auditorium in the basketball court, basically, where we hold the actual competition. So there's a lot of forethought that goes into making the facilities that we have here at WPI work for robotics. In 2018, we built a new building called the Innovation Studio, and it houses a lot of classrooms and other spaces, but it also houses one of the teaching labs that we have here. So this is the lab where you would take, where you would do courses in the first couple of years of your career here, RBE 1001, Intro to Robotics, and then a couple of the second year courses. We just more recently built Unity Hall. And in fact, we just moved into Unity Hall just a couple months ago, and it's so new that we don't even really have some pictures on the inside of it now. But the bottom 2 floors are occupied by the robotics department. We have some space for doing capstone projects. We have some research labs. We have our offices, and then up on the top floors are classrooms that we like to use for our courses. So robotics. Robotics started off as cartoons, if you will. Here's Robbie the robot, and you probably know a lot about robotics from industrial automation. So here's some robots that are putting together a car. Maybe you have an iRobot that cleans your house. You can imagine all kinds of robots that are used to drive around in complex terrains and do things. Here's an aerial robot. Here's an underwater robot. Well, we saw that robotics was becoming more and more important in industry and in life. And so back in 2006, 2006, we started the program. And in 2007, we had the first enrollees in robotics engineering. So we were the first program in the United States to offer a Bachelor of Science in Robotics. That went so well that we then added a Master's of Science in Robotics. And then that went so well that we ended up having a PhD program in robotics. So we're the first institution to offer the BS, the MS, and the PhD in robotics engineering in the United States. We are fully accredited. In fact, we just had an ABET accreditation a couple years ago. So they review, basically ABET reviews the program and make sure that we are basically doing what we say we're doing. And so you can graduate from an accredited program in robotics engineering. In fact, we won the ABET Innovation Award a few years back for our program. It turns out that when we first started robotics and we first wanted to get accreditation, that there is no accreditation in robotics. We were the first one, right? So there was no accreditation criteria for robotics. But we do so well at it that we're not just getting accredited, but we're also kind of defining what robotics is, because we're at the forefront of robotics education. And so faculty here are actually steering the ABET boards and so forth to define what it looks like for robotics and mechatronics and automated systems and so forth. So robotics is very popular in New England. Here's a map that shows companies and institutions and universities and so forth in the Boston area. The Boston area has a lot of robotics. Over 2 billion robots, $2 billion worth of robots sold, 52 robotics companies. I think that these numbers are a little bit stale because we haven't had a chance to update them this year. The average salary in robotics is $130,000. The average starting salary for a robotics graduate from WPI last year was $85,000. Globally, robotics is booming. We have companies that come to WPI every now and then and say, we will hire all of your robotics engineers next year if need be, and so forth. And it doesn't actually happen that way, but there's lots of demand for robotics graduates and lots of demand in the job market out there. So robots take many forms. Perhaps you're familiar with the Segway. We have lots of space robotic projects that we work on. Here's a balancing wheelchair, humanoid robotics. even a robotic toaster in this case. These are robots that you might be familiar with. Here are some robot projects that we've been working on here at WPI over the years. So on the top left is, I believe it's called Prometheus, which was an early prototype for a robotic vehicle. Top center is a robot that was used that's used in a class to help students learn about wheeled vehicles and how to control them. We have soft robots and snake robots. So here's a snake robot with a very highly articulated robot. The penguin in the lower right is actually used for medical intervention to help diagnose and treat autism. Another robot on the lower left there that's used in classes, and then in the bottom is Moonraker, which was developed by a WPI student who was the first one to successfully complete the NASA Regolith Challenge, and he actually won $500,000 for the project that he created here at WPI. So what is a robot? In person, I usually ask this as an interactive question, and we usually hear something about sensors and actuators and intelligence and so forth, and all of those are correct. We define a robot as something that senses the world, computes or takes action or makes decisions about that information. It acts on those decisions, so it has actuators, and it exists in the physical world. So it ends up being a cycle, right? We sense the world, we make decisions, we act on the world, and then we observe the results of that. And so we have basically a feedback loop so that the robot can continue to do the tasks that it needs to do. If you wanted a single line definition, we might say that robotics is the intelligent connection between perception and actions. So it's more than just an automated system that does the same thing over and over and over again. There's some level of decision making, some level of intelligence in there. And our goal in robotics is to help you, start from the basics and work your way up to where you can create robots and have them do useful tasks in the world. So it used to be that robots were used for the 3 Ds: dull jobs, dangerous jobs, and jobs that were dirty. That served as a good definition for a while, but we've kind of moved beyond that. And the reason we've moved beyond that is because the components that go into robots, sensors, computing devices, communications, actuators, the cost of those have come down dramatically in the last decade or two. And then we've seen the potential users, defense, security, medicine, entertainment, whatever, the need has risen correspondingly. And so the intersection of people are seeing the value and the usefulness of robots and our ability to make them better and cheaper and faster and more robust means that robotics is it's taking off, it's exploding. So at WPI, we treat robotics as a fundamentally multidisciplinary problem. So there are aspects of many disciplines that go into it: electrical and computer engineering, mechanical engineering, computer science, other disciplines as well. Fundamentally, robotics is about how do you take all of these things that seemingly don't have anything to do with one another and put them into a system that can do more than the sum of its parts, if you don't mind the cliche. So we give you an innovative and immersive combination of the fundamentals, and then we take that theory and we put that into practice, and we show you in our classes how to put all that together into a robot. So the nice thing about all of the core classes is that in every class you have a robot. Either you've built it, you've constructed it, sometimes we give you one that you customize. Sometimes we give you a fancy one that has a very more complicated architecture to it. But in every class you have a robot, and the class ends with a demonstration of what that robot can do. That's designed to have you prove to us that you can apply the theory that we've discussed in the class and put it into practice. So you get project experience in classes, you have opportunities to perform high quality research, you can make industrial relationships through internships and so forth. And I'll touch on each of those in a little while as as we continue on here. So at WPI, we have an innovative project-oriented education. I'm sure you've heard about project-based many times. We have a very flexible curriculum in that it's really, it's part of your job to figure out what you're ready for and what direction you want to go. And it's our job to help guide you in that direction and give you the advice you need to make you successful. It's a fantastic university to undertake, to learn about robots. It's a great place for me to work and be at the forefront of robotics education. And I think that's what makes it a really special place. As you may know, we have decades of experience working with FIRST Robotics, FEX Robotics, NASA competitions, lots of competitions that we're involved in. And again, I'll touch on some of those coming up here. Ken Stafford, who's with us, has been very heavily involved in FIRST, and he loves to ask people what FIRST team they're on. So if you're in FIRST and you want to put in the chat what FIRST team you're on, I bet he may recognize some of them and be happy to talk to you about it. So in 2006, Ken Stafford and others saw the need for creating a robotics program, and we started off with one course, one lab, one faculty member, and 0 majors. The program formally started in 2007, and so that's when we started having robotics majors. It has grown many times over the years, and currently, latest count, we have 32 different courses, 16 labs, including teaching labs and research labs, 19 core faculty, 20 associated faculty. We're actually hiring some more faculty this year as well. We're up to about 425 undergraduate students by my last count, and 280 graduate students. We have over 1,200 alumni. And not only do we have the BS and the MS and the PhD, we also have an online master's program. We offer a robotics minor, and we offer a graduate certificate. And speaking of the graduate program, if you stay and decide to do that, we've begun to start some very noteworthy training programs. Rose Hub, which is a nice industry university consortium. Forward, which is all about training the next generation of educators in STEM in general, but robotics in our case. And we have the women. We have a program for women in robotics. Actually, we have a program for women in STEM here at WPI to help increase the number of women who are working in STEM fields throughout the country. So we've been so successful that in 2020, we said, let's create an engineering department. Previous to that, we were 3 different departments: computer science, mechanical engineering, and electrical and computer engineering. But we all work together as on the robotics program. And robotics has gotten to the point where it is its own discipline unto itself. And so we said, hey, it's time to create a robotics department. And so in 2020, we did. Now, the faculty in our department still maintain affiliations with other departments, mechanical engineering, but mostly mechanical, electrical and computer science. But we also have faculty in those departments who are affiliated with robotics engineering. We have other faculty that are affiliated in other departments as well: aerospace, physics, chemical engineering, even some social sciences and policy studies, humanity and the arts. And basically what that means is that it's not just about building a robot to do a very narrowly focused task. It's about working with people from other departments to find real world problems, important problems out there that they may be aware of, but we in robotics are just hearing of them. And so we can work together and we can develop new robots that can solve all kinds of lots of problems. So it really gives a big opportunity for our faculty and our students to do a lot of collaboration across the university. So speaking of competitions, again, many of you may be familiar with FIRST. WPI has a long history with FIRST Robotics. We also have a program in Savage Soccer where students come and do competitions there. We have alumni who have gone on to win the BattleBots. So the same student who made the Moonraker robot was an early winner of the BattleBots competition. Here's the Moonraker robot again. We still enter lots of competitions in space robotics and so forth. So here's Ken Stafford with a robot that was used for, I'm going to say a NASA challenge, but I'm going to also say I don't really know, but luckily he's here on the chat, so he can probably type in exactly what this robot was for. You might have heard of Battlecry or been involved in Battlecry. Here is an Atlas robot, which is doing the DARPA challenge, where they had to program a robot to get out of a car, walk down a hall, walk up some stairs, open a door, and so forth. And WPI did so well that we were given actually one of these very fancy robots, which we still have and we use for research and classes in humanoid and leg robotics. And I should say that Ken Stafford made many of these slides, and he's very much into sailing. And so we've had a long-running Capstone project in automated, basically a robotic sailboat. And this sailbot, as we call it, I believe has won the national competition. I want to say 3 times. I know 2 times, but I believe it won another one recently. So it's a very successful project that we sponsor here at WPI. This is the current BattleBots team. Ribot is the green robot on the left. This is in action against, it looks like MIT. There are parts flying and sparks everywhere. And if I recall, this was a pretty exciting match. The current season is being shown right now. I think WPI is still in it, but I don't know the details off the top of my head. So, coming back to the program, the objectives of the program are to provide the students with a foundation in the core disciplines, mechanical, electrical, computer science, and so forth. Give you the practical skills to help you design and construct robots that address human needs and desires. We actually have a requirement for what we call the entrepreneurial requirement. So you take at least one course that's geared towards entrepreneurial activities because robotics are the field is still growing so rapidly. We want you to be aware of how you can take advantage of opportunities if you choose to go that direction. Maybe start a company, maybe work for a startup company or so forth. And we also have a requirement for social implications. So you get to talk about, discuss, and develop your own opinions on social and ethical implications of robots in society. So the curriculum looks something like this. Again, it's very flexible, but we start you off with some introductory courses in the core disciplines, CS, ME, ECE, and also an intro to robotics course where we kind of bring it all together. And then typically in your second and third year, you'll take the robotics core courses, which are focused on actuation, perception, manipulation, navigation. And these courses are supported by lots of courses in science and mathematics, linear algebra, embedded system programming, mechanical engineering, statics. If you want to take dynamics, great, that sort of thing. And then typically you'd move on to some advanced courses, and we have some long-standing courses in industrial robotics and mechatronics, and we have more recently developed some new courses in manipulation, human-robot interaction, artificial intelligence, and so forth. And then there's a whole slew of electives. ES&D stands for engineering, science, and design. So there's a whole slew of electives that you can take in other departments as well to help you develop a specialty in robotics, develop the specialty that you want to develop in robotics. And then it all culminates in the major qualifying project, which most people would call a capstone, but we call it the major qualifying project here at WPI. And major qualifying projects can come from different ways. Sometimes they're generated from professors who are doing research, for example, in medical robotics or mobile robotics, robot assistance. Sometimes they're industry sponsored. I'm working on, I'm advising an MQP right now where we're developing a robot that can detect and mark buried electrical cables, for example. So it drives around and it moves this little wand and it detects cables and puts the spray paint on so that when people come and want to dig up the street, they know where not to dig so they don't get electrocuted. And then there are student-generated MQPs. So a group of students says, we have a great idea for an MQP. They formulate a plan and a proposal, and they shop it around to different professors, and one or more professors say, this sounds like a great idea, and they'll advise that project as well. So lots of ways that you can do your capstone when you get to that point. So a list of the undergraduate courses, the courses in blue are the core courses that I mentioned before that you would take typically the 2000s in your second year and the 3000s in your third year, but doesn't, you're not beholden to that. A list of higher level classes and electives. You can also take graduate courses as an undergrad here. So we have a number of graduate courses that students can take, and these courses can be either theory focused, like robot control or computer vision, for example, or they can be kind of domain focused, for example, soft robotics or biomedical robotics or something like that. So if you're really interested in biomedical robotics, you could take RBE 580 and get a specialty that focuses on that. And a lot of undergraduate students do take graduate courses. They typically do very well. They're not meant to scare you off or anything like that. So it gives you a lot of opportunity to do other specializations. We also have some special topics courses. These are also graduate courses. These aren't guaranteed to be offered every year, but most of them have been offered for the last 2 or 3 years, and we expect that they'll continue in some form in the future. So it gives you another chance to specialize and learn about a very focused topic in robotics. I'm going to put up a typical program here, although to be honest, it's not quite typical, or there is no typical program here at WPI, I'll say. Essentially, I've packed all of the free electives at the end of this. It'd be rare that you took all of these free electives in your senior year, but they're grouped there to kind of give you an idea of the flexibility of the program. So the courses in yellow are robotics courses that you have to take. There are several other courses here that are required courses, particularly in the sophomore year in this layout. But there's a lot of overlap with some other majors, ECE, CS, and ME in particular, and there's a lot of space to take additional courses. So it's not uncommon for students to double major here, particularly if you come in with AP credits. But even if you don't come in with AP credits, it's still possible with some careful planning. So speaking of capstone projects, or coming back to capstone projects, here's some examples of some projects that we've run recently. We have a hexapod over here on the left. Here's our penguin again. We have a legged robot over here on the right. There's a glove in the middle, so that's all about how can somebody use a device like this to pillar operate something, perhaps, or get that sensory feedback like they are grabbing an object or something. We have some mobile robots down in the lower right. Looks like I don't know what that one. I thought it was a medical robot, but I think it's some kind of industrial robot. We have some aquatic and underwater robot projects that go on. There's a huge variety. So there's a large variety of projects that faculty are doing for their research. There's any number of ideas that students generate, and again, we have some industrial partners as well. So we have lots of different whatever it is that you want to work on. There's a good chance that you'd have a chance to do that here. As I mentioned, some of these projects are sponsored by companies. Here's a select list of companies that have sponsored our projects. I say select because I hope I haven't left off any important ones. But a lot of the names that you're used to seeing, Amazon Robotics, Tesla, General Dynamics, and so forth, are up here. We have great relationships with a lot of these companies. A lot of these companies have hired our students, and so that helps with internships. That helps with generating new projects, and frankly, it helps with getting our students jobs when they graduate. So one of the let me see if I can get this video. So here's one of the Capstone projects from a few years back. The team wanted to make a robot that could handle most any kind of terrain, and so they created this robot with rocker wheels that allows it to go over rocks, as we saw. They fabricated it basically from scratch, so they applied a lot of mechanical engineering skills to designing the chassis and building the chassis. A lot of electronic skills in integrating all of the motors and the sensors and electronics. Obviously, programming skills to get it to do the things it needed to do. Here's a MATLAB simulation of it going over a rock, or a brick. And lo and behold, it actually go over the brick. Here it is out in the field, driving on a power line right away, demonstrating its prowess at going over the quite varied terrain. It was made to be able to handle payloads, so they can put a camera on it here, and they can then do a lot of testing. So now they can do a teleoperation, because they can see what the robot sees, and then they can control it, in this case, back in the dorm room, or the lab, remotely. So not only are they able to test it that way, but they're able to demonstrate some very impressive functionality of this robot. And this was sponsored by a number of groups, as you can see here, and is really a very impressive MQP. Let's see if I can go to the next one. So again, I mentioned that we have great relationships with a lot of companies. Here is again a select list of companies where our graduates have gone on to get jobs or have gotten internships. It helps to have graduates from WPI at a lot of these companies, because it gives our students somebody to talk to, get their foot in the door, and so forth. And then knowing how well our students, our graduates perform at these companies, it gives our students a good way to introduce themselves and get those internships. If you, maybe you're looking more to go into a research-oriented direction, again, so we showed some of the Capstone projects. Here are some of the other research projects that are going on. So we have some soft robotics down there in the lower right. I'm co-advising a team that is actually in Scotland right now, because they published a paper in a well-known soft robotics conference, and they all decided they would go to Edinburgh and present the paper and enjoy their senior year, if you will. So we have industrial manufacturing robotics, biomedical robotics, human-robot interaction, lots of stuff developing new sensors and new way to manipulate things, mobile robots, humanoid robots, leg robots, and so forth. It's quite common for undergraduates to work in research labs here. So even before you get to your fourth year, when you're doing your Capstone project, you can go talk to professors and work in their labs doing all kinds of exciting things with robots. And as you develop more skills and you do more and more things, and you can really get deeply involved in some of the excellent research that goes on here. So with that said, for more information, as you are probably already aware, you can visit robotics.wpi.edu. On that site, you can find a list of faculty. You can find my email address, Ken's email address. There's a general email that you can send, rbe@wpi.edu, if you have more questions. Obviously, you can contact Sydney or anybody in the admissions office. But again, congratulations on your acceptance, and I hope that you find WPI an interesting place. And if you're interested in finding out more, you're welcome to contact us, or you're welcome to ask more questions right now. So I'm going to stop sharing my screen. And I know that people have been answering questions in the chat, or asking questions in the chat, and that the others here have been answering them. But if you want to type more in the chat, you can do that, and we will try our best to answer. Are there any women in the RBE program? Yes, at the moment, it's still, the program is still male dominated. It's about 70%, 30% male to female ratio at the moment. I will say that I am part of, I'm actually on the diversity committee here in robotics, which is about making robotics what we want it to be, right? We want to make sure that everybody has an opportunity to go into robotics and everybody has a chance to prove themselves. And we also want to make it such that everybody feels comfortable and has a place here in robotics engineering. So I'm expecting the ratio to even out a little bit, but it is what it is. It's about 70-30 in our courses at the moment.
In terms of this traveling a component of undergraduate projects, yeah, it's common with essentially every major through IQP, because IQP is generally done off campus. There are a couple MQPs that are also done off campus, and I think robotics is one in Switzerland sometimes, or some years. So yeah, you can it's also in the robotics program too.
Just anecdotally, we've also had WPI MQPs and robotics done in Japan in the past. And I'm here in Morocco working with a robotics group as well right now in Africa.
So there's a question in the Q&A, is there a learning curve that I must adjust to since I did not come from a robotics background? So, I mean, it's fairly obvious that if you have a robotics background, you may have a little bit of a leg up on certain aspects of the program. But in reality, what we're trying to do is make sure that that students look at robotics from kind of a unified perspective, if you will, meaning a formal perspective. So while having skills in CAD or programming or something like that can be useful, we're very conscious of the fact that everybody comes in with a different skill set, and it wouldn't be an educational program if our goal wasn't to educate everybody in how to make robots. So we provide a number of resources for students when they come into the program. Each of the classes, from the intro class through all of the core classes, has what I like to call a fleet of students to help you out. Typically 2 teaching assistants, at least 4 student assistants, and those student assistants are drawn from undergraduates who have been through the course before. So in fact, both Ash and Tom have applied to be student assistants for next year. And so they've been through the course before, and so they know kind of what the trials and tribulations are and where the pain points are, if you will. And so we have lots of resources to help somebody who comes in as a novice be successful in robotics, because that's what we want, right? We want everybody to be successful, not to say, oh, just say all the people who already know robotics, so great, you get to be in our program. That's not what we're about. We're about making everybody successful.
Yeah, I can address this question about the mechanical engineering, especially since I started in the mechanical engineering department and then we moved over to the robotics engineering program. I will tell you that the design of the program was designed to be easy in, easy out. And if you looked at the schedule that Greg presented, you could compare that first year with virtually any of the prime engineering curriculums for the first year, and it's quite similar. And so the answer to your question simply is, yeah, it's quite easy, in fact, to go from either direction, from mechanical engineering to robotics engineering, or the other direction too. You know, as a 10-year or 12-year instructor of their introduction to robotics programs, a lot of MEs take that with no intention upon becoming a robotic engineer, and they change their mind maybe after they've taken that. So it's really quite easy. Is it what you can say the same thing, Tom? What were you going to say?
I was gonna continue just to the other question that um can you adjust if you come with no robotics background? Like I'm international, I didn't have any first experience or anything, and I would say I've done well in the courses. If you manage to plan out your schedule well and you can easily catch up to also the people who have done first for a long time or something or FRC or something similar. Um, and you can definitely be at the same level. Like the fact that you don't have robotics background definitely does not mean that you would be left behind in any means.
And then speaking of switching majors, if you recall, Ash said that she just added a CS double major. So maybe Ash, you want to talk about how easy or difficult that happened to be.
Yeah, so I had some AP credits coming in, not like a whole bunch, but I was able to like get ahead on some math classes. And then I was jumping around, I was like, do I want to do a co-op, which means taking a term or two off, or do I want to graduate early? And I was like, I want to take some more CS classes since I'll have some free space in my schedule. And then before this term started, so I think it's been like 3 weeks now, I decided I'm going to double major, and I talked to my advisor about it. And I needed to sit down for a few hours, look at, course catalog and like, what do I actually need to graduate with both majors? But I was able to come up with actually multiple schedules that would have, fit the requirements for both majors. So it's definitely doable. Sometimes it means putting in a little extra effort, like taking some grad level classes or maybe overloading one term or something like that. But it's definitely very doable.
And then someone in the Q&A asked about, Tom, about the MSBS. Are you graduating in 4 or 5 years? Have you had a chance to do co-op internships, or would they delay your graduation?
Yeah, so I'm trying to graduate in 4 years. And the way I've essentially, I didn't come with any AP credit. As I said, I'm international, so we don't really have AP credit stuff. So I essentially had to do basically all the courses. You can still definitely do a co-op or an internship, especially if you have a lot of AP credit. I worked for one summer, my freshman year to sophomore year summer, I did have to take 3 courses to maintain my schedule. And I've had to overload every semester to be able to do that. But if you do come in with a lot of AP credit and you don't have to do that, you can definitely get an internship, like even after your sophomore year. After freshman year, it's usually more difficult. So it's I don't think that's too common, but after sophomore year, after junior year, you can still definitely get an internship or do a co-op if you want to. It doesn't make you graduate. The important thing is that you just manage to plan out your schedule really well, and you definitely want to have ask questions about like how to plan the schedule and move into the courses. Then there was another question of examples on how hands-on learning is applied to robotics engineering. I would say in all of the RBE courses, you do something physical with some type of robot. Like in RBE 1001, when we did it, we used a couple different types of romies to pick up packages and basically deliver them somewhere. In 2001, you design and build your own robot, and in 2002 you use a physical robot and basically different sensors too, so it senses around the environment. There's with every single RB course that I have taken, except for maybe social implications, but that's theory, you will be doing something physical with a robot, and it's a big part of the grade, and it's a basically I would say a large part of the course, a very large part of the course is the projects.
Let's see, somebody asked, are there people of color in the RBE program? There are a few. Maybe, let's see, so the classes are averaging about 60 at the moment. Maybe a handful of African Americans, a number of Asian students, a number of Latino students as well. I don't have numbers off the top of my head. Again, as part of the diversity committee, we're looking at ways that we can make sure that that everybody has a chance to study robotics, and make sure that people from different backgrounds are able to join us. But it's yeah. So and you know, in response to that, we hope that those numbers come up. But that's about where we are at the moment.
Yeah, I will say that I know that there are definitely clubs around people of color on campus, and they've managed to do popular events. Like I think last week there was a fashion show that they did on campus that seemed to be rather popular. I'm not really in them, so I can't really say much more, but I know that a lot of people went there.
In response to the diversity issue, you might also comment, or I will comment, that WPI, besides being the first university to have a robotics engineering undergraduate degree program, we were also the first chapter of WIRE, which is Women in Robotic Engineering. So that there's a big support group for, especially for women to, although they do not, I believe, and perhaps you can correct me on this, Greg, I don't think you have to be a woman to join the Women in Robotics Engineering organization, but that's what it's designed for, is to support.
Are there any more questions? Okay, well, again, thanks for attending, and I think we'll wrap it up. Sydney, I guess I'll let you have the last word here so that you can finish up. Thank you all.
Awesome. Thank you so much. Thank you so much to everyone for presenting and sharing a little bit more about robotics. I know it's really helpful to get all those questions clarified about projects and what can happen after WPI. So this was really great and really helpful. Again, anybody watching, if you have any other questions, please feel free to reach out to me or to the robotics engineering department. We can get those questions answered for you. But again, thank you so much. Congratulations, everyone, on your acceptance, and have a great night. Bye.
Thank you all.